Okay. I don't know where my chat window went. Oh, there it is. Okay, yeah, we're taking notes. So ideally, I'd like to do more problem solving in class, but I have to do some notes first to back this up. We're going to talk about measurements today. Measurements. So a measurement is basically, it's the process of comparing let me move my notebooks here. This is not ideal setup. And when I did this last semester, I was just making videos. So,
are we taking attendance at class?
What's that?
The attendance.
Oh, attendance. Yeah, what I can do is I can just look at the attendance, who logged in. That's why it's important for you to have your name on the when you log into Zoom. Have your name and your last initial at least, so I can pull up the attendance after the Zoom meeting's done. So I don't actually have to do a roll call. If you have another professor doing that roll call, then they don't know that trick. So yeah, I mean, here's what I would recommend. As you go through the videos online and as you go through the, as I take notes or write notes here, treat it like you're, a regular note-taking class. Even with the videos, don't just watch them. It really helps. It's been shown that you learn and retain better if you do all three things. You see it, you read it, and you write it. You see, you hear it, you read it, and you write it. Seeing and reading are typically the same. So you read it, so you see it and you hear it, and also you write it. It just helps you retain the information better. So that's my recommendation, even with the videos. The nice thing about the videos is you can pause and rewind. And I do have, when I do the videos, sometimes I'll have slide decks and I'll put them up there. So you'll have them. But still, there's something about writing in your own handwriting that seems to help with retention. Okay, so measurement is the process of comparing a physical quantity to a referent. That's a referent. And if you can't read my writing, you're probably not the only one. So ask me, what's that letter or what's that word? And a referent is a measuring instrument. So example here is a ruler. Excuse me. A scale, gauge. Could be a pressure gauge. It could be a micrometer. So all measurements have units, right? When you measure something, excuse me, you use some system of measurement like, meters or feet. And because we have units, let's talk about units here. There are 4 fundamental properties of nature. And those are going to be what give rise to the units we use, right? So we have time, we have length, we have mass, and electric charge. So these are the four fundamental properties that give rise to the different units we use. You know, obviously the easiest one I think is, well, time and length, right? Those are obvious, seconds, minutes, hours. But length, we have a bunch of different systems for that, length and mass. You know, we have English system, we have SI units, we even have some UK properties. So these can only be defined, these are defined by how they're measured. And we also have from these, we have derived properties. And these are based on fundamental properties, right? So, for example, you have area, right? This is the extent of a surface. And this is, you know, for example, there's a rectangle, right? And the area is length times width. So, you know, this is a derived property because, you know, both length and width are a measure of a fundamental length, right? So you have a length times a length. So if you have, say, meters times meters, you have an area which is meters squared. So that's a derived unit, right? It comes, the fundamental unit is meter, it's a length unit, but area is a combination of those. And then you also have something like volume. This is the amount of space. Oops. Occupied. Did I spell occupied wrong? So something occupies a certain amount of space, right? And that's a volume. So volume is typically a length times a width times a height, right? This is just an example. This would be like a cube, or a, you know, something like this, this stack of Post-it notes, right? It's got a length, it's got a width, and it's got a height, right? It's got a certain volume. So the units on these are going to be meters cubed, feet cubed, right? So we've got length times length times length. You know, inches cubed, centimeters cubed, and you can go on and on. Okay, so those are derived properties. And from this, we've got measurement systems. So a measurement system I'm going to fit this all on one page. Is just a set of base units a governing body agrees on. And scientists use the SI system. That's
A
the
governing
Hello?
body, what?
Oh, that's a misspelling. I forgot a G. Oh, that's agrees. Oh God. Agrees on. Yeah, I forgot a G, sorry. my hand thought the A and the G were the same. What do we got? We got international system. So yeah, again, just do what you did. You see a word that you can't read. Let me go to the next page here. I'll move this up so you can see it still. So the SI system has 7 base units. So for each property, there's a corresponding unit. Unit. We have length, mass, time, temperature, this is amount of a substance. We have electric current. And finally, luminous intensity. Anyone know what the length unit is? You can either type it in chat or just say it. Anyone? Can I guess? SI unit. You must have had this already in high school, right? The unit is meter. So I'm going to put so I'll write it out and I'll put the abbreviation for it. So length is typically measured in meters, but the SI unit is based on it's a base 10, so you can talk about decimeters and centimeters and kilometers. And we'll go into those prefixes later, right? For mass, we have a kilogram. What do you guys think time is? Nobody. Seconds. I don't know if that made it worse or better. And then temperature, the units on temperature I think for this one, a lot of people want to say Celsius, but it's not, it's Kelvin. And Kelvin is an absolute temperature scale. And we'll talk about what that means later on in the course. Amount of a substance. This is the mole. And the abbreviation for this, they just cut off the E. I mean, you can't really use M because that's meters. They could have used MO, I don't know. But that's the mole. And the electric current is measured in amperes. Symbol for that is A. And finally, luminous intensity is the candela. I think now if you go to the store to find light bulbs, the LED bulbs, you'll see you can find the candela rating at least more prominent than it used to be. You know, we used to shop for light bulbs by watts, right? But now now they all consume, the LEDs consume less power, so we don't know what we're doing anymore.
Could you move it to the left a little bit?
Move it to the left. Like this?
Yes, thank you.
Oh, is it cut off?
Some of the wording was a little bit.
Is that my screen or your screen?
Maybe mine?
Oh, okay. Where's my mouse? All right. Let's see. We can cover. So I just want to make a note on conversion here. At some point, you're going to start converting units. Let's see. Maybe I should do this first. Yeah, I'll just do the conversions. So sometimes you have to convert from, say, meters to centimeters, right? Or you have to convert from meters to feet. So let me just give you some notes on conversion. Typically, the formula you're going to use is going to look like this. So give me a minute to draw this out. I'm going to use two different colors. Let me do the blue first. This is what you start with. So you're usually given a number, right? And that number is what you start with, and you're also given a unit. So units, you start with. I'm going to put these notes in after I do this. Now, give me a minute to just draw it out now. The N1 and N2 are just number 1 and number 2. And this is going to equal something. These are the units you want. This looks confusing, and we'll do an example. All right. So let's, basically you start with a number, it has certain units. These are the units you start with. You set up a ratio with two different numbers. One has the units you want, the other one has the units you start with. And mathematically, these units are going to cancel each other out, and you're going to be left with the units you want. And again, it's much easier to see in an example. Let me also write a note. N1 and N2 are chosen such that the top and bottom are equivalent. That's an and sign. It's really. So let's look at an example. You're given convert 8 liters to gallons. So what do we do here? We say, okay, we have 8. The units on that are liters. I'll just write out liters. This is the number we start with. And this is the units we start with. All right, now we have to go to some kind of conversion table and find out the equivalent numbers. So we want gallons, right? The units you want to go on top. So let me write gallons up here. And the units you start with go on the bottom. Right? So you go to some conversion table and you look this up and you see, oh, you know what? 1 gallon is equivalent to 3.786 liters. Right? So that's how many liters are in 1 gallon. And this is your ratio. And mathematically what happens here is you multiply the 8 by the 1 and you divide by 3.786 and you wind up with 2.1. And the units on this, liters divided by liters is, it's like 2 divided by 2, it's a 1, right? A 1 is, in dimensions, they cancel out. So liters cancel out and you're left with gallons. So you wind up with 2.1 gallons. So this is the conversion formula. I threw it in here. I thought it was, we'll use it later on and you'll see more conversions. So are there any questions about the conversion here now? Okay. So those are converting between, so that kind of makes sense, right? You've got different units, you've got to convert between them. This is a way you do that. I want to do a few more things on measurements. Oh, did I already write this? Hold on, let me check. Yeah. Measuring with a device. So if you're using metric devices, there are certain rules about measuring. So this is for metric devices. So when you use a metric device, the measurement must be made to 1 decimal beyond the smallest increment on the device. So whatever measurement device you're using, you look at the scale and you take a measurement just beyond that. So for example, here's a ruler, right? The ruler scale, forget the inches on the bottom, we're looking at the centimeters on top. So the major marking is centimeter, but we've got smaller markings, right? Small increments of millimeters. So we would take a measurement to the decimal place beyond that. So we'd say 10.15 millimeters. So let me draw something out because that ruler is kind of small to see. Say I had some object here, and I have a ruler that I'm using to measure. That's 27. Let me see if I can make some increments. Oh, sorry, I zoomed in. One, two, three, four, five. There's 28. So say this is in centimeters, right? Length of A. So this is A. This is some object I'm measuring, and I've got a ruler which goes on in either direction. But you can see here I'm at 27, and so my measurement is 27 point. My smallest increment is 1/10 of a centimeter, right? Or a millimeter. So I've got 1, 2, 3, 4, 27.4. And then in here, I'm going to look at this. I'm going to say, you know, it looks like maybe 6, right? You could say 5 or 6, you know, either one is fine. So this is the smallest increment and this 6 is the estimate. And we need something, we're missing something here, we're missing units. Put the units on here. So the length of A is 27.46 centimeters. And the reason they do use this convention is if you're looking at your lab notes or something, right, and you always use this convention, you know, okay, I wrote this number 27.46. Oh, you know what? I must have used a ruler with the smallest increment being 1/10 of a centimeter. So it gives you some idea of, and again, if everyone uses this system, it gives you an idea of, okay, how, excuse me, how accurate was this measurement, right? What kind of device was using it, or was you being used to measure it? And that's important if you're trying to replicate data or something, or you're trying to understand, all right, how much error do I have in my calculations? You can kind of go back, and we're going to discuss significant figures in the next section. But so that's measurements. And let me put another example on here. This is a graduated cylinder. So a bunch of you may be taking classes where you need to use graduated cylinders. Let me see if I can draw this. I'm gonna have to move this up. So let's start at, I don't know, 40 here. All right, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's right. All right, so I have this graduated cylinder. And I'm going to flip this on the side here just a minute. I'll put it back up as soon as I draw this out. It's harder to draw. All right, this is my rendition of a meniscus. And I'm going to put a little line here. Okay. So this is a graduated cylinder, and you're looking at this, and these units are in, so let's put increment is a milliliter. A lot of times people just write it with a small l. So that's the increment, right? A milliliter. Does anyone want to guess what they think the volume is?
$45.5.
45.5. Okay, so 445. So here we have the smallest increment is the milliliter, right? So we've got 1, 2, 3, 4, 5. We're right in the middle of that, sort of. So the estimate is exactly like you said. It's going to be like that, 45.5, right? Because this is the smallest increment. And this number, or 0.5 here, is the estimate. So yeah, that is correct, 45.5. And we can't forget our units, milliliters. Yeah, and then to summarize basically what I said up there, all measurement devices introduce some degree of uncertainty. Oh, period. For each measurement, someone complaining about my writing. For each measurement, there is a process. Is a process that tells us how many digits should be, that's an H, represented in that measurement. I'm falling off my desk here. And my hand keeps slipping. Measurement. Makes my writing even worse. All right. So all measurement devices have some degree of uncertainty, and there's a process. This is the process, right, that tells you how many digits you should represent in that measurement. This is sort of a standard, if you will, that people use for metric devices. I don't actually know. I'm trying to think of what we would do in a like inches. I mean, I've sort of rounded in inches too, because we measure down to tenths of an inch. All right, so I used to, this is interesting, just an aside here. I used to work at a company where there was a lot of measurement that was important to do on some of our products. And we're talking about finding things, you know, you had a machine shop, you also had products that were being finished down to certain specifications, so maybe thousandths of an inch. And people had to take measurements to make sure things were within specifications. And we used different types of tools for that. And we actually had a guy on site who was basically a calibration, or he was the guy that calibrated all the instruments. So if you ever want, if you know someone who's really, really OCD about things, the old term used to be anal retentive, but you know, someone who's really you know, rigid about, oh, things have to be in the right order and this and that. That's a perfect type of job for these guys, because so this guy used to take our instruments, and once a year he would calibrate them. And what that meant was, if you had a caliper, which is just a device that measures thickness, you had a caliper that you were using, he would take that from you, he would bring it to a room that he had that was at a controlled temperature and humidity, and he'd let it sit until it came to the right conditions of that room, and then he would compare it against a reference device, and he'd make sure that it was within tolerance. That reference device, he actually sent in once a year to the National Institute of, what is it called? Oh, I can't remember the name. National Institute of Standards and something or other, maybe technology, it's NIST. He would send it in, and they would compare that device against the national standard, or I think it's a regional, I think it's like regional and national. So the point is that there's actually an entire system devoted in each country, devoted to making sure that measurements are accurate. Because when you're trying to measure things like in machine shops, or you know, you're trying to build very accurate devices, you want the measurement devices to be accurate as well. And he would do things, he would send back, we had instruments for measuring temperature, we had instruments for measuring, well, the mass ones, they used to have someone come in. So one day I was in the lab working on a balance, or working near a balance, and the guy came in to calibrate the balance, and he had a whole suitcase of masses, and he opens a suitcase and he's wearing rubber gloves. And I went to touch one of his masses, and he's like, "No, don't touch it." And I said, "Oh, sorry." And he explained that these masses are calibrated, or not calibrated, they're compared to the national standard, and they have to be handled with gloves so you don't get any of your finger grease on them, especially for the very light masses, right? You can imagine you're trying to check a balance to see if it's accurate to 100th of a gram, and someone's gotten their greasy fingers on your standard, and you're going to be off. So there's actually an entire industry devoted to making sure people's measuring devices are accurate. So that's where I'll end here, and hopefully I've given you some appreciation for the amount of effort that goes into taking accurate measurements. It's not just, yeah, look at a ruler, and that's the, I mean, for most of us in our everyday lives, right, it's like, okay, yeah, look at a ruler. Our paper is, what is that, 20 21.62, maybe. You know, if someone else could say 0.61, but that's how you do measurement. So I'll see you guys. Oh, Monday is Labor Day, so there's no classes. Look out for Blackboard announcements because due to the Labor Day thing and due to this whole course section movement, I'm going to have to send some announcements either through Starfish or Blackboard. And try to get into your book today before the let's say before 3 o'clock, if you can. And that way you'll at least have access. I know you'll have access when the course moves over because you'll have already set up an account in McGraw-Hill. So go ahead and do that before 3 o'clock today. All right, any questions before?
I came in like 10 minutes late. I was having some internet issues. Would I be able to just get the first part of the notes where it has listed length and electric charge?
Yeah,
It's easy to find by how they're measured.
Let me stop the recording here.